Hello learners, this is Education Online program. With you is teacher Rose Hezekiah, and I'm here to present for you a lesson in chemistry for senior 1 and 2. Our topic for today is a continuation of the periodic table. We are going to look specifically at members of group 4 and group 7. So if this is our periodic table, we will be looking at group 4 and then group 7. So in group 4, as I mentioned earlier, that elements are placed in groups based on the number of electrons in their outermost shell. So in group 4, all members of group 4 have got 4 electrons in their outermost shell. So the first member of group 4 is carbon, and mostly members of group 4 is called the carbon family. So we have the first element is carbon, followed by silicon, germanium, tin, and then lead. So these are members of group 4. Group 4, as I said, group 4 is called the carbon family, because the first element in this group is carbon. So we have the first element is carbon, atomic numbers C6. Then we have silicon, symbol Si, atomic number 14. Then we have germanium, symbol Ge, atomic number is not indicated. Then after germanium we have tin, Sn. Then we have lead, atomic number Pb. So tin and lead are the symbols are taken from their Latin names. So we have carbon, silicon, germanium, tin, and then lead. These are members of group 4. So around in this group we have carbon. We have carbon is a non-metal. Carbon is a non-metal. Then we have silicon and germanium. Silicon and germanium are metalloids. They are metalloids. Having shows they display both properties of metals as well as non-metals. Then we have tin and lead are metals. We have tin and lead are metals. So in this family of group 5, so carbon is a non-metal, silicon and germanium metalloids. Then we have tin and lead are metals. So these are members of group 4. So carbon is the second most abundant element. Carbon is the second most abundant element after oxygen. We find carbon in so many substances. It is found in almost all living organisms. So, carbon at the same time exists in many forms. So, carbon as an element, it exists as diamond, this is one of the most precious minerals. And then carbon exists as graphite. Carbon exists as diamond and graphite. And then, as I mentioned, I said carbon is found in almost all living things. The proteins we get in the structure of proteins, we have carbon is there. The food that we eat, we have carbohydrates. We have carbon is there, and carbohydrate is a product of a plant. Then we have silicon. Silicon is mostly found extensively in sand. It is found in sand. It is in abundant form also in sand. So sand itself contain ground up particles. Sand contains ground up particles of minerals. So in sand we can get particles of minerals, which is for example like quartz. So quartz is a mineral that contains silicon. It is composed of silicon, composed of silicon plus oxygen. So we get this in sand, and quartz contain silicon and oxygen. And as I said, silicon is abundantly found in sand. And then also we have glass. Glass is a product, is one of the important products that is made from sand. Glass is a product of sand. It's made from sand. And then glass is used also in abundant form. We have the glassware materials. Then we have silicon and germanium. As I said, silicon and germanium, they are metalloids, and they are used as for making semiconductors in electronics. Then we have tin and lead, which are metals. Tin and lead, which are metals. They are the heaviest elements. We have tin and lead. They are metals, and they are one of the heaviest elements in this group. So lead is mostly used in making shields to cover up our body in the process of X-ray. Lead is used to shield the body from unwanted X-ray exposure. Lead is also used, it is used to make shields from unwanted X-ray exposure, because we know that those rays also, they are harmful to the tissues in our bodies. So if we are taking X-ray, we need to cover ourselves, and we cover ourselves with shields that are made of lead. We also get lead in car batteries. Lead is also found in car batteries. That is, the black material in car batteries is lead. So lead has got low melting point. Lead has got low melting point. So because of this character, lead is used in making alloys. Because it has got low melting point, it is used in making alloys. An alloy is a mixture of two or more metals. Usually 2 or more metals are mixed together to give us a different product. So then we have these alloys will be used for protective shielding around nuclear reactors. As I mentioned, I said lead has got low melting point. It is used in making alloys, and this alloys is used for protective shielding, that is covering. It is used for protective shielding, that is a protective material, a cover around nuclear reactors. Around nuclear. So we use a shield that is made up from an alloy that contains lead. It is to protect us from nuclear reactors. And then also, these alloys can be used for, these alloys that contain tin can be used for making containers. Can be used for making containers. That is, these containers can be used for storing and transporting radioactive materials. For storing and transporting radioactive materials. So we know that radioactive materials are harmful to our bodies. So while transporting them, they need to be stored in containers that will not allow this radiation to come out. So alloy of carbon will be used for making containers, and these containers will be used for storing and transporting radioactive materials. So tin is used in toothpaste, as a pewter in toothpaste, and then it is also used as a coating. It is used in coating steel, cans used for food. Used for food. So the tiny coat that we see in cans that is used for storage of food, that coating is from tin. So this is mostly about members of group 4. As I said, group 4 is made up of comprised of carbon, or it is called the carbon family, because carbon is the first element among members of this group. So group 4 sometimes is called the carbon family. So in group 4, carbon is a non-metal, silicon, germanium are metalloids, tin and lead are metals. Then let us look at group 7, and group 7 members are known as the halogens. The halogens. And halogens mean salt former. They form salts. We have group 7. Group 7. Members of group 7 are known as halogens. And halogen means salt former. They form salts. So all elements in group 7 are non-metals. All elements in group 7 are non-metals. And of course, all members of group 7 has got 7 electrons in their outermost energy level. So we have, this is group 7. We have the first member of group 7 is fluorine. And as I said, group 7 is known as the halogens. So, in group 7, all are non-metals except astatine. And then astatine is a radioactive metalloid. So we have fluorine, chlorine, bromine, iodine, and astatine, which is a radioactive metalloid. We have fluorine, chlorine, bromine, and iodine are all non-metals. So, they form salts. We say that the halogens, the word halogen means salt former. They react with other elements to give us salt. For example, we have chlorine. In group 7, period 2 can react with sodium in group 1, period 2 to give us sodium chloride, which is table salt. So, for example, we have sodium chloride, that is NaCl. This is the chemical formula. We have sodium is a member of group 1, and then chlorine is a halogen from group 7. The two can combine or can react to give us a compound called sodium chloride, and sodium chloride is a salt. So all of the halogens form similar salt with sodium and with other alkali metals. So we have all the halogens in group 7 can react with all the alkali metals in group 1 to give us the same salt. So we can have fluorine reacting with lithium, sodium, chlorine reacting with sodium, or chlorine reacting with potassium to give us the same salt. So out of the members of group 7, fluorine, that is the first element in group 7, fluorine is the most reactive non-metal in group 7. Fluorine is the most reactive of all the halogens in combining with other. So we have the halogens, members of group 7. We have fluorine, chlorine, bromine, iodine, and astatine. So we said fluorine, chlorine, bromine, and iodine are non-metals. We say that astatine is a radioactive metalloid. So reactivity starts from fluorine, is most reactive than chlorine, is most reactive than bromine, and then bromine is more reactive than iodine, which means that reactivity decreases as you move from top to bottom across a group. As you move from top to bottom across a group, in group 7, reactivity of the elements decrease. So, from this group, among this group, iodine is the least reactive. Iodine is the least reactive non-metal. So, we have fluorine, chlorine, bromine, and then iodine. As I mentioned, I said these are non-metals. And all members of group 7 has got 7 electrons in their outermost energy level. And then they form salts with the alkali metals, the same salt. And we have the common salt, that is sodium chloride, is formed as a result of reaction between the alkali metal sodium and then the halogen chlorine. So they are called halogens. Halogen means salt former, that is, they form salts. So all halogens form similar salt with sodium and with other alkali metals. And then we said astatine is a radioactive metalloid. Dear learners, we have come to the end of our lesson. See you in the next lesson. Bye bye.